All right, welcome back everybody. This is the homework section of Integrated Math 2, Practice 5, Square Roots and Cube Roots. And we have some square roots as well as cube roots that we have to simplify. There are 12 of these, right? Let's go ahead and jump right in. I like to come out here where I have all this space to do my work, right? I don't always like cramming it in here if I don't have enough room. So I'm going to come out here to the side, and I'm looking to simplify the square root of 75. And the first thing I think about with 75 is 75 cents, right? And 3/4, or 3 times 25, would make 75 cents. 25 is 5 times 5. So it looks like a 3, a 5, and a 5 are what I get when I break down 75 in its prime factorization. Since I'm under a square root, I'm looking for groups of 2. I have it, a pair of 5s. That means 5 gets to come out to the front, and left inside will be this lonely 3. So the square root of 75 is 5 square root of 3. How about the square root of 135? Okay. So right away I think, all right, this ends in 5, so I want to divide by 5 and see what this makes, right? So I'm going to get out my calculator here. And I'm thinking to myself, okay, what is 135 divided by 5 actually make? And it makes 27. So 5 times 27 is 135. 27 can be broken down into 3 times 9. 9 can be broken down into 3 times 3. So what I notice is that under a square root sign, I have a pair of 3's, and I have an extra 3 and an extra 5 left over. So the 3 gets to come out to the front, but this 3 and this 5 have to stay inside. And if they're both staying in, they're going to multiply each other. So what I will end up with is a 3 on the outside, and on the inside, 5 times 3, or 15. 3 square root of 15. How about the cube root of 56? Since I'm under a cube root, I'm actually looking for groups of 3 this time, not groups of 2. And for 56, I think of 2 times 28. 28 is 2 times 14. And 14 is 2 times 7. That's as far as I can go. Did I end up with a group of 3? I sure did. 3 2's. So a 2 gets to come out to the front. Remember that it's still multiplying a cube root, right? Root of 3, root of 3. And left inside was the single 7. So 2 times the cube root of 7 would give me that one. I'm going to let you guys do the next one on your own. Let's go to 5. Some of you may already recognize that if you know your times tables pretty well. This is actually a perfect square. Square root of 144 is really the number 12, because 12 times 12 is 144. But I do want to show you what would happen if you were to break this down all the way. We get 2 times 72, then 2 times 36, then 3 comes to mind times 12. 12 is 3 times 4. 4 is 2 times 2. Now keep in mind that you could do this a different way. You could think of 2 different numbers to start with. As long as we do it correctly, we would end up in the same place. But notice I have a pair of 2's, a pair of 3's, and another pair of 2's. So everything is coming out, right? All this stuff got broken down, so it's not there, and there isn't any singles left over. So a 2 is coming out, 3 is coming out, and another 2 is coming out, right? 2, a 3, and a 2, and they will all multiply each other. 2 times 3 is 6, and 6 times 2 makes 12. The cube root of 1,000, right? Looking for groups of 3. This is also a perfect cube, if you don't know that. But if we come over here and break it down, you'll see that. What can make 1,000? 10 times 100 is 1,000. And 100 is 10 times 10. I could break down the 10s into a 2 times 5 and a 2 times 5, but honestly, I've already got what I need. I was looking for a group of 3, and I found it. 3 10s. Since everything would come out and nothing would be left over, that means this is a perfect cube. The cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. Right? about the square root of 108? Square root of 108. I would think 2 times 54 makes 108. 2 times 27 makes 54. 27 is 3 times 9. And 9 is 3 times 3. Since I'm under a square root, I'm looking for groups of 2. So I got a pair of 2s, a pair of 3s, and then there's going to be a single 3 left over. So the 2 is coming out, the 3 is coming out. When they both get out there, they're going to multiply and make the number 6. And left inside is going to be a 3. So there's a 6 on the outside, and on the inside is 3, or 6 square root of 3. All right? Cube root of 320, I'm going to let you try on your own. Square root of 6, this is interesting, because if I try to break down 6, I can, and I'll get 2 times 3, but then I have to stop. 2 is a prime number, 3 is a prime number. I can't break them down without using the number 1. I could call 2 1 times 2, but that ain't going to help anything, so we don't use 1s. And I was looking for a pair since I'm under a square root, but I don't got one. So 2 and 3 is all that's in there. I have to conclude that the square root of 6 is already simplified. That's as simple as it's going to get. Same is true for the cube root of 9. If I break down 9, I can go 3 times 3, but then I have to stop. I can't break down either 3 because the only thing that breaks down 3 is 1 times 3, and we don't use 1s in factor trees. That's what makes 3 a prime number. And under a cube root sign, I'm looking for a trio, 3 of something, but I don't have that. I've only got 2 numbers here, so the cube root of 9 is as simple as it's going to get. I'll let you guys try the square root of 567, and I'm going to do the cube root of 250. All right, 250 could be 1 times 125. 125 can definitely be divided by 5. What would it make if you didn't know? 125 divided by 5 is 25. So 5 times 25 is 125. And 25 could be 5 times 5. Gone, gone, gone. Since I'm under a cube root, I'm looking for a group of 3. There they are. I got 3 5s. So a 5 gets to come out times the cube root of this lonely 2 that is left inside, like so. All right. Hope that helps, and I will catch you guys in the next class.